gonna get started. So if everyone who wants to take a seat takes a seat, we'll get going. All right, so I guess this is the crew. Today we are going to talk and show some efforts that we did on multi-cluster, multi-cloud, highly available application stacks. And this is it's like a kind of sneak preview on something that we're working on. It's let's say a working prototype, and our colleague Tim, where are you? There he is. He is putting a lot of effort into getting this to work, and we've been working on this together with Elotl. Madri will also say some things after, and so the basic idea is that we want to be able to offer something very, very, very stable, right? And scalable. So with just one cloud provider, you'll only get so far. And then, of course, you can do multi-region setups, but I thought, why not go multi-cloud? It's not so different, right? So we started to think, what are the components that you need to worry about? And the main component that I thought was difficult was the database, basically, because that's where your state is. That's what really needs to be synchronized across the clouds. So we started to Google what are the options, and I came across a thing called Lyco. Tried it out, couldn't really get it to work. Was like, okay, I got somewhere, but it wasn't entirely done. Then it was like Admiralty, which isn't really, how do you write that? It's not really meant for high availability. I think it's more, this kind of says it's the easy way to do multi-cluster and allows you to scale to multiple clouds. And then at some point, my colleague told me like, hey, we're in contact with Elotl. Is that something? And they were really positive. We started to talk, and I told them like, well, maybe we can get this, a really, really stable multi-cloud setup to work. And we started to work together on getting a very standard or compatible with the standard stack. So basically, the idea was to have, I'm just going to get, what's this bold move? I mean, this is, okay. So the idea was to basically have something that you can run anyone's software on, right? Because the thing is, you can do a lot of things with computers, but you want to be able to run the things you're used to, right? So I thought, well, what does everyone use? Everyone uses either like MySQL or Postgres, right? Who uses MySQL? Who uses Postgres? What? There's some other stuff. So basically, I thought, so I wanted to do something a bit like one step further than just clustering these systems. So for MySQL compatibility, we went with TiDB, which is it's a highly scalable database that's MySQL compatible and is really, really built for clustering. And for Postgres, there's CockroachDB. So we just started to see if we could get it to work, right? And all of them, that was a bit of a challenge, of course. So first thing you need to do is you need to take each of your clusters. Well, first of all, you need 3 clusters, right? And from the documentation, TiDB actually, we read, well, these clusters need to be able to find each other by pod IP and by the DNS domain of the server, so service. So then we started to try like service meshes and different ways of connecting the clusters together, and like a point-to-point VPN and a bunch of different stuff. In the end, we got stuff to work with Scopper. And I guess the reason that was in the end the one that's most, it's just the one that's most compatible. So we tried Istio, but it had it doesn't support headless services, which like the TiDB operator uses. So it was changing the DNS of the services. So basically, if you were trying to connect to a service from here to here, then it would change the name. So by default, it wouldn't find it either. So there was a whole bunch of stuff that we understood how to fix but didn't want to fix, right? So we thought, okay, let's just try another one, or actually Tim said that, and then he installed Scopper and stuff started to work. And then in the first step, we actually we installed CockroachDB, and the idea was like, okay, we want to have a very, very standard like e-commerce solution running. And we tried a couple of different ones, but found out like, okay, there is actually some incompatibility between like Postgres and CockroachDB. They're supposed to be compatible, but it's compatible with like wire protocol, Postgres wire protocol. And you can, then we switched the database driver of the web shop, so to CockroachDB, and stuff started to work. But we found out like, okay, this does require some adjustments. So we adjusted some code and it worked, but still has some bugs. So if you are in full control of your code base and you're building your own software, okay, fine. You'll have a test suite. You run your test suite and just fix it where it needs to be fixed. But I wanted to do something that's really, really applicable out of the box, right? So we switched focus to TiDB, which is MySQL compatible and is more compatible. and well, also MariaDB compatible, of course. And it didn't work at once. There was like a couple of settings we needed to adjust, but we did get it to work, and also more or less out of the box in the end. So that was nice. Okay, I'm gonna turn on the projector again. So I'll just show you the application and the stack. So in the end, we went for a TiDB database clustered across Leaf Cloud, OVH, and Fuga Cloud. Fuga Cloud is another cloud provider in the Netherlands. OVH is a big French cloud provider. And we use the Kubernetes as a service of all of them. I think all of them are built on Gardener. We're using also our own beta of our new Kubernetes as a service. And so this is the setup I was talking about. So basically, the end user comes in. Currently, we have a Cloudflare load balancer. That's another like moving part that we're actually going to do differently. But there's still a kind of a to-do there. We're going to decentralize this, basically. And so the way it works, there's like TiDB instances in each of the clouds. They are registered to each other, and Scupper interconnects them. And the only thing that's really connected between the clouds is the database, because the web server, well, in itself, it doesn't really need to communicate with the other clusters. The only thing that you hit is that, like, a standard website will often upload its images just to like a directory, right? So we ended up using an S3 compatible object storage. We're using our own object storage for this, but that's also part we're still going to decentralize, because you can actually decentralize that. And we multi-attach it. So there's like an S3 CSI drive. Do you guys know what everyone's very silent actually. How's the pace? Yeah, is this clear?
Yeah.
Yeah, okay, cool. So I will show some. No, okay, I'm going to show the website, and then I will show some of the configuration and parts. So basically, this is the Kubernetes cluster. This is the website that we're running, and this is just currently a kind of default WordPress WooCommerce setup, and it's just a shop, and then well, you buy stuff basically. But the nice thing about this is that we can actually we can kill the cloud at which this is mostly ending up, and the shop will keep working. There is some failover time at this moment yet. I think we have like 15 seconds, but we're going to actually bring that down. So the part, so we're load balancing this in Cloudflare, and right now we have 3 healthy ones, and we're sending things to OVH, and we can here just reroute stuff to Leaf Cloud, for example. So let's say 98% goes to Leaf Cloud. Save. Confirm. Then we actually going to bring down the entire Leaf Cloud cluster. Well, not our own infrastructure, of course, but the Kubernetes cluster. So here, these are the instances that are running our worker pool. And this is the Gardener interface on which we're running the Leaf Cloud Kubernetes cluster, which I will just hibernate. And then it's going to start to take down the instances. So this will actually start kind of the failover process. Still working. So I just keep clicking some stuff. So let's see. Use context. I'll just go to OVH. And here actually, you won't actually see, aha. So we have some failover kicking in. So you might notice that right now there is like a short time, so there was actually like some error and the failover had to happen. That's because of this part. We'll zoom in on that. So currently this works. So I guess the Leaf Cloud cluster is actually down. Yeah, they're gone. And the website is not. Right? That's kind of the point. And we can circle that around. So the chance that your production website is going to go down is actually very, very low in this way. I'll just bring up the Leaf Cloud part again. Wake up. So I have another page in which we zoom in on some of the challenges. So we talked about, is this readable? Is this readable? Yeah? So, well, intercluster networking, we went with Scupper. There are some challenges in regard to performance that we're still ironing out. I mean, works okay, but I want it to work like really fast. And I guess we're not entirely there yet, but it's very scalable right now, but there's still latency. So, even though the latency between the cloud providers themselves is like, it's just a couple of milliseconds, like 3 to 5 or something. So we had to set some system variables. So when we started the backend of WordPress and the migrations ran, they failed initially. And that was because TiDB by default has no op functions set to off, which kind of just crashes the migrations in some cases. And we turn it on, even though I do recommend making sure that everything works, because it will actually pretend to be doing that it's not, some stuff that it's not doing. I'm not sure why we had set this one. New installations enabled on first bootstrap. We had to set that to false for the migrations to work too. And did I zoom in on it here? No. Okay, I will do it on the whiteboard. So basically, basically a traditional load balancer. So if you just use the load balancer, it's going to you have an entry here, right? It goes to 1, 2, 3. So call them 1, 2, 3. And load balancer is going to do health checks, right? So failover is only going to work at the moment that the load balancer realizes, well, you're unhealthy, and then starts to reroute the traffic only to the other ones. And the load balancer itself is still a single point of failure. In this case, Cloudflare, I do think they have highly available load balancers with, I mean, they're quite good. But the point was kind of to have this entirely, like, no single point of failure, not only by, not only technologically, but also, let's say, politically. Like, part of the idea is also not to be dependent on a single company, right? That's kind of cool. If you do multi-cloud, if everything decentralized, then when one of the companies makes like a network mistake or whatever, it won't matter. Now if Cloudflare makes a mistake, we're still out. So the idea was, well, the idea is to do this a little bit differently. So basically, decentralizing this one, right? So instead of a load balancer, what we're going to do is, and hopefully this will be done at the next demo, but the idea is to have each cluster, well, each of these clusters have their own load balancer, right? And the ingress. And the idea is basically to use internal BGP. So is everyone familiar with BGP, or everyone or anyone? Who is familiar with BGP? Okay, a little bit on the right, a little bit on the left. So basically, what BGP allows you to do, it allows you to bring your own IP address range, basically, right? So I called Fuga Cloud and I called OVH and said, like, what do I need to do to use my own IP addresses with you guys? And Fuga said, well, we're going to arrange it. So they're sending a network engineer at some point, and we're gonna pair. And the guy from OVH said, well, okay, we have bring your own IP, so that was kind of nice. So you can do your own BGP configuration. Point is that we can basically bring the same range. Well, we have this range, for example. X is one of our ranges, and I can route this to leaf Fuga and to OVH. And the nice thing about that is that there's actually multiple ways to not have to load balance in this case, because load balancing, the internet can load balance itself, basically. So we will just put like 195.114.30 dot, I don't know, actually replicate this to there, and to there. And now the internet is going to balance itself, right? It's just going to choose the shortest path to this IP address. And because the web application, it doesn't matter which endpoint you hit, you always get the same state. This is actually just going to work. And so then the only challenge is to know on time when one of these clouds fail, basically. So you can actively monitor the connection between them, or you can monitor the connection between them with VIP, and you can monitor the health of an entire, let's say, reachability of the cluster itself. In BGP, you have a thing called BFD. So BGP has a thing called BFD. And BFD is actually actively going to tell the upstream internet provider. So basically, you get your internet from, I don't know, let's say it's KPN. Or in our case, one of our providers is Atom 86, for example. And between them is a BGP session. And here it's between us and OVH. So basically, OVH is here. It's also BGP. And this is going to allow the IP address to be routable to these clusters, right? So that BGP session allows the IP address to live in either place. BFD is going to monitor if this connection is healthy, and it's going to be communicating with your router here. And the moment that it fails, it's got this. This router is going to be informed by this router, and this router is also going to be informed by this router that failover needs to happen. And you can set this to be like half a second. So then the failover will happen really fast, and the rerouting of the internet will go instantly to the other location. So then the need for having a load balancer basically disappears, and you can have a fast failover between your clusters purely by using the internet protocol itself. Yeah, so let's zoom in on to do for the load balancer. Any questions? Yeah.
What you explained now will only work if the full data center goes down, right? The router where the BFD is connecting to, because if the cluster itself is going down, the router will still be active. And with the load balancer, you can kind of work around it by performing another health check.
Correct, correct. So there's other challenges that you will want to do there, basically. One thing that Tim suggested to do is to actually use Istio between the clusters and have Istio reroute that part. So that Istio will monitor the health of the web application and start routing to the other ones. But the fun thing is that if the cluster goes down, your Kubernetes cluster's ingress goes down, you can actually fail over this IP address. So that's where VIP comes in. So there's a couple of layers of like stability that you can add with different approaches and protocols. Was there still another question? I saw someone's hand going up. No?
No, I was in the same direction.
So with VIP, you can actually, instead of failing over the entire network, which would require the entire network going to, like the network to go down, you can monitor the health of this IP address and the reachability of it, and fail back over and just like place it somewhere else. So you can also move the IP address itself if you want to. So instead of replicating, you can have like 164 in the first cluster, 165 in the second cluster, 166. And these are not. These are actually things that we at LeafCloud do for parts of our infrastructure. So these are things I'm not very familiar with them, but I've done, let's say done them before. And so you can actually have these active on each of these. Then have your DNS pointing at all three of them. And the moment that one of them fails, VIP can place them in one of the other clouds. So then two of the IP addresses will be in one place. And in that way, you can deal with a slightly different set of outages, basically. Yeah.
If you put them all in your DNS, doesn't that completely negate that you're routing via BGP? Because DNS knowledge is unknown which your browser will connect to.
Well, as long as they exist, it's okay, right?
Yeah, of course they will connect to something, but then with BGP Anycast, the whole idea is that you connect to the closest.
Yeah,
It's
yeah,
the
yeah.
whole idea of multi-region setups. But by putting all three IP addresses in there, you don't control anymore where they connect to.
Depends a little bit how you do it, but I see your point. Yeah, I mean, you could.
My point
I
is,
guess
if you put them in DNS, there's no reason to do BGP anymore. Because DNS, actually, if you can't connect, it will retry the next one. It just has higher latencies.
I don't think it will actually try the next one. Because I don't think DNS is going to check if your website is up.
No, most browsers will try the second one if the first one fails.
Right. Right.
Now, this is kind of part to answer the question.
Yeah.
Depends on the failure mode.
Yeah, no,
Like,
it's all experiment.
There's some failure modes in which your browser will retry the second available, but there are others where there's no response. It might take a very long time for the browser to realize anything else, and then it's.
If one router says that IP address does not exist, it will go to the next one mostly. But if routers just drop it, then it will take a while.
We've tested this with our object storage. Wasn't super. Yeah. In the end, we opted for having the VIP set up and failing on them over between entry points. But yeah, I guess I have the feeling that there's like a DNS solution that we didn't fully explore yet, because there's also dynamic DNS, but I'm not sure.
That's CKL, so that's also something.
Yeah.
But it's nice to see like all the pushing out the single points of failures.
Yeah.
But there's still a single point of failure in your system now.
No.
Your DNS provider.
No, because you have multiple DNS providers. We have two. So, yeah. And DNS is always like that, right? You always have multiple DNS providers.
And you take them from separate entities as well.
Yeah.
And you're not on .io.
No.
The root of .io goes down once in a while.
Really?
Yes. There's a nice blog post around that.
Oh my god, that's not great. Okay. So I think, so where we're gonna zoom in on other stuff. How long should I talk? Also a question. So maybe something that's nice to talk about is the volumes. So basically, that's the other kind of major challenge, right? In getting stuff synchronized. And well, as expected, when the first time we deployed, the image uploads weren't properly working. So currently, what we have is we just connected to our Ceph storage. So what we did, there's like S3 CSI driver for Kubernetes. So CSI drivers are basically drivers for your persistent volumes in Kubernetes. And there's a whole bunch of them. There's like lots and lots of storages that are compatible with your persistent volume claims in that way. And it happens to support multi-attach, so that was great. And it's compatible with our Ceph storage. So we use Ceph for object storage at LeafCloud. So we just connected that to Ceph, and then Kubernetes basically just creates volumes there. And then we basically just multi-attach that to each of the WordPress, right? WordPress. There are WordPresses in it. So I don't like WordPress. That's not the reason that I chose it. It's just so, it's kind of stupidly default. Like, it's so normal, and I just wanted it to be a very normal stack, right? So that's why it's WordPress. Because everyone understands that if you want to do custom stuff, you'll get there, right? You'll get there. You'll be able to write your custom code and get it to run on the different clouds, but it's more about doing a very, very, very standard setup and also getting that to work there. Then your custom stuff hopefully will be a breeze, you know? So we just multi-attached it to each of the clouds. And basically that just worked. I was kind of surprised. Tim was also surprised. But that there was one thing that you had to make sure, and it's that you like predefine the ID of the volume, right? So you cannot dynamically create a persistent volume claim. You have to set the volume you're mounting in your container, so it's the same one. But it's kind of obvious, right? So the next step on that, because so now we have single point of failure again, right? It's the Ceph at LeafCloud. So there's a couple of options for actually pushing that single point of failure out again. So the idea is, so what can you do to spread your volume? Yeah, basically. So of course, our Ceph deployment is highly available, etc., but it's still in one cloud provider, right? And we don't want that. So one thing you could do is just deploy your own Ceph across 3 cloud providers. I do not advise doing this. Maintaining Ceph is a pain. It'll work, but don't do it. I don't think so. So there's another thing that I want to try to do, and I think it should work. There's actually kind of ledgery storage that's called Storj. And on top of this, you can put S3 compatible gateway. And Storj is decentralized. So that's exactly what we want, right? We want a decentralized storage. And so then the idea is to have each of the clouds connect to Storj with the S3 gateway. And then you just have 3 gateways, one in each of the cloud, connecting to decentralized storage, and then that single point of failure is also gone. And then you can, so right now I destroyed the Kubernetes cluster, but I didn't destroy Leaf Cloud, right? And so the idea is that if, I don't know, someone at FuelGap makes a mistake, their entire network is unreachable, it won't matter at all. So yeah, I think that was more or less the last. That's more or less the last single point of failure. So you might notice I am really focusing here on high availability. There's also scalability that, of course, it comes also with multi-cluster. You have the plus of doing scalability across across clouds, but I think it's actually a less difficult thing. So in that way, kind of less interesting, and I think it's also more solved. So yeah, this is we were zooming in on high availability. Other stuff. No, that's more or less it. So just to go back. That's the basic stack. So we're still pushing out the single point of failure here. We're still pushing out the single point of failure there, and these are yeah. That's our setup. So thanks. Are there any more questions for me? I think Madhuri will continue talking. Yeah.
With your current BGP solution, do you expect any problems with long-lived connections like WebSockets? I'm not sure how BGP works. I wouldn't use it in production for a work, but I would assume that it's not deterministic, the route from client to the server side, so it can end up in a different cloud provider from the same client. Or am I mistaken?
A single connection, I think it will not be rerouted because your connection is still on.
Because this is below TCP. This is a packet level, so if you're routing update, the TCP string will break unless you transfer state from one cloud to the other.
I think you might be right. I'm not entirely sure.
Is it layer 3?
But you seem quite sure about it. Because BGP itself works on layer 3.
And there's way too many TCP sessions going over routers to keep track of net address translation.
Right. Yeah. So the BGP setup might
Your application just needs to
not like it. If you replicate the IP address, that is. Yeah.
Right? Because if you use Kubernetes, everything can happen within the cluster. The port can die. You also need to reconnect.
But there are definitely details like that, and that's also what we noticed. Most of the stuff will just work, but you definitely need to pay attention to details that the less standard details that you have in your stack. You do need to think about them. Yeah.
As inter-cloud data traffic is quite expensive, what
Yeah.
do you do to minimize the cost? Or is it?
I'm not minimizing costs right now, but basically, you can for the reads, you can set your reads to read locally. So the web server, it's configured with the local copy of the database, but you want them to replicate across clouds. So yeah.
But the multi-attached, if you have it, I would make sure you have a local cloud local cache.
Yeah.
Thing,
Yeah.
So you don't go.
Right. Yeah, I think so. In the setup with storage aid, we'll actually have that. Yeah, it does have a local cache. You had another question?
Yeah, it's like really fascinating to go that deep on BGP to do any cost. But what's the business case? Because if Cloudflare goes down, half the internet is down, we need to get the board games out anyway.
I mean, cloud, yeah, it might not be worth pushing that out. I think I think that's right.
If Amazon US East 1 goes down, we need to get our board games. So.
Well, the point is kind of if Amazon goes down, you don't need to be down, right?
No,
and
it's like if US East 1 is down,
yeah.
half the internet is down. Happens twice a year.
Yes.
Yeah, but you don't need to be down. I mean, that
I know, but like
down,
nobody
right?
will go to your website because half the internet is down.
If they know you're the only website out,
Yeah.
they'll
Yeah.
shop on your website.
Maybe,
We're
but
on, but Amazon is down.
I think a lot of stuff doesn't need to be done, and we don't need to be so dependent on the Amazon data center, right? And I do
we
think there's a
shouldn't.
big,
So
yeah.
this is noble, but
Reality is different.
Well, I do think like if you do want to buy food at the supermarket, it is actually important that it's not down the moment that Amazon is down. And there are a lot of things that you don't want to be down when Amazon is down, like your flight control center or telecommunications. Or a lot of things are actually critical past Amazon US East, you know?
yeah,
Yeah,
I mean,
basically, yeah.
the future will be terrible with telcos moving into clouds.
Yeah, they are. Well, they are with cloud providers.
Sorry, not to make this an open discussion, but I had an interesting chat with the guy with Tenet.
Yeah.
So they operate the high power grids in the Netherlands. They actually do have a cloud deployment, but they also have this like there's national security level requirement to not go down, and so they have also their on-premise system with completely synchronized maps to solve exactly this problem.
Yeah.
Oh, right.
But I think what I really appreciate about your story is that it shows how you can eliminate these problems, and I think then for all us DevOps and engineers, the question is, okay, so which parts do I want to eliminate? Where can I find solutions? And then there's of course a choice. There's your business, of the business case, which do I need to pick? Like maybe it's enough to use a replicated database. But it's cool to see.
Thanks.
Yeah, I think if you have multiple clouds, you can scale up the one that's most cheap. So if you have multiple and you see the prices are going up there, then you maybe you can shift workload more to the other one. So that could also be one. Yeah, that's easy.
Anything else? Then, yeah.
Did you have any brief look at the options for NoSQL like databases? I mean, like, yeah, you have MySQL covered, you have object storage covered, but.
Well, we have, for example, Redis running. TiDB runs on top of TiKV, which is also a key value store replicated. I didn't deploy, for example, MongoDB yet, but I do know it has a clustered. There's a couple of things going through my mind, but it does have a clustered setup that I've used before. But I think that, yeah, it's kind of a next step. So what database do you have in mind?
No, not really, just wondering.
But I guess
Most NoSQL databases will be easier because they work on different failure. How to describe it? Within Capterium, it's on binary. It's a rating scale. If you take Cassandra, for example, you can run it quite natively across multiple clusters, especially if you have your networking figured out. And your application will always hit your local one, unless you want like durable reads, but then you need to cross clusters. It's mostly the relational databases that are like problematic in these setups.
I think also what's nice about Scupper compared to the other network solutions that we tried is that we didn't have to change a lot, and it seemed like most of the things just like work by default.
That's probably until you try to stress test it, really.
Maybe.
It's
Yeah.
still an empty Locust shop. Yeah, like consistency problems kick in, and it's any kind of DNS, BGP flipping, whatnot. That's done before, yeah.
We'll get there. We will have to kick it a bit more probably still. Yeah?
Could you list the networking solutions that you went through that didn't work? You mentioned Istio. Any other stuff that you tried?
Istio, and I tried Lyco.
Okay.
And Lyco, I think it's worth another shot, but it felt, I didn't get it to work within a day, and I was a bit like, I'm not sure if I'm going to keep bashing my head against it. Submariner we tried for a couple of hours. Scupper was how long did it take to get Scupper to was also the easiest. So just if Istio works well, but it just changes a couple of things.
Was no support for headless services?
Yeah, no headless services. Yeah. So then I think it's time for me to really leave the stage.
One
Yeah.
question.
Yeah.
How do you manage your clusters? I mean, in terms of communication, interaction with API, and do you try some solutions to consolidate this, or just? Do you know what I mean?
Yeah. No. So currently we just deploy to each cluster separately. But Nova is actually going to solve that. So Madhuri will tell more about that. Yeah, yeah, yeah. Thank you.